What is up, guys? Hope you're doing well. Today we're going to be covering a super important programming paradigm for embedded systems and firmware engineering, and that is the finite state machine. And in this video, I'm going to use a super simple example that should be really easy to grasp, and that's a simple coffee pot controller. And we're going to walk through two different ways that you could implement this controller. The first of them will be the super unprofessional spaghetti code solution, which might be kind of your default if you don't really know much about state machines and you're just implementing a brute force solution to this controller. And we're going to point out some of the main issues with that spaghetti code solution, and then we're going to show you guys the super clean, nice, readable, finite state machine solution that once you see, you won't be able to unsee, and you will always hopefully use before you do a weird spaghetti code solution that doesn't work and is not professional at all. So let's get right into this simple coffee pot controller logic to help you guys understand the code a little better. So we have four different states. We have our idle state of our coffee pot. We have our heating state. So this is if we've added water and we want to heat that water up to boiling almost, right, to pour over our coffee grounds. And then we have brewing, which is assuming that we added coffee grounds, and we have our boiled water, and we are pouring that boiled water over our coffee grounds, right? And so from idle state, we can go either to heating or to an air state. We can't go straight from idle to brewing. And then from heating, we can either go to air. So if we're heating and for some reason there isn't water in a pot, we want to turn off the heating element, right? Because we don't want to burn up the heating element and waste energy. So we need to go to air, turn that off. And then we can also go to brewing, right? Once we've done heated the water and we have some coffee grounds, we would want to do a state transition to the brewing state. And then brewing can only go to idle. So in this simple coffee pot controller, if we're brewing the grounds, pouring hot water over the grounds, there's not really an error that could happen, right? I mean, maybe something crazy happens, like impact the coffee pot, but we're not going to worry about that right now in this simplified solution. We're just going to say brewing can only go back to idle. So that's the controller. Let's get into the code. So this is the first example of the code. This is the spaghetti code, the bad spaghetti code, right? And to represent the state, we essentially need these four Boolean flags. So we need to know, is it running? Is it heating? Is it brewing? Does it have an error, right? And we need to maintain the state of these globals. We have our global water flag, right? So these are kind of representing the state coffee pot. And then we have our state transition function, which is the process input function. It's going to take in an external event and modify our states. And so basically we have like these if statements to say, okay, if the event is 0, so that maybe that's like a start pressed, right? Then we want to check, is it not running? Does it not have an error? And if water level, then we need to set our flags. Boolean flags are globals, so we're modifying globals inside this function, which is horrible programming practice, right? Hopefully you already know not to do that. But we also have these like weird Booleans, like why isn't this just representing struct, right? Why do we have these magic numbers here? Why aren't these enums? Like there's a lot of issues here, right? And then we kind of walk through our different states. So we need to check if this event happens, temperature is reached. We need to check, is it heating? Does it have an error? So we're basically having to do these weird logic checks to really check the state. This is what we're doing here in these ifs, is we're checking the state, right? And then we're also doing this check of the event. And we're constantly modifying these global Booleans. So just think about it, right? If we want to add some state, like we want to add a cleaning state, right? What are we going to have to do? We're going to have to do so much work. We're going to have to add a Boolean. Then we have to go through manually all of these if events cases, and we're going to say, okay, do we need to modify this to say, like, is it not in cleaning? Do we need to add modifier is cleaning flag in here? Do we need to modify it in here? Do we need to modify it in here? Do we need to modify it in here? We need to go through all this logic super carefully because it's all the logic representing the states, right? So we kind of have to look like, what is this weird, like, not flag, and, like, it's just to add something, right? And then let's think about, like, if, like, for example, if we're in, like, heating and, like, brewing at the same time, like, what happens? What happens if we click the start button? The event is 0, and we're, like, heating and brewing or something. Like, what is going to happen here? Like, is this going to happen? Like, are we going to have an error if the water level is, like, getting low? Are we going to restart the whole event if, like, we click the start button, right? Are we going to go start brewing again or heating water again, like, even if we're already brewing? Like, it's just kind of messy, right? So it's really hard to read. So let's look at the clean finite state machine solution. Okay, but I mean, this is just gorgeous, right? No globals to worry about. We have this really readable code where we have our different cases that are just for different states, right? So if we want to add a cleaning state, we just go here, boom, case cleaning, right? Like we just do something like that. And then we can just add logic to our cleaning case. And if we want to look at, okay, what's this idle, what's happening in the heating state? If we're in the heating state, we're just checking the event flag if temperature's reached, and then we're just transitioning to brewing state, right? So super clean, super readable, super tidy, no modifications to global variables, right? So now and then we can just look at this, the header file, right? So this is basically free. And we have this really nice struct to represent the state of our coffee machine. We have our current state of our coffee machine all represented in one variable, as opposed to here, where it was like 4 different global booleans, right? I mean, like, that just sucks. Then we have these nice clean enums. We don't have magic numbers, so hopefully you guys can appreciate like why this is so much better and why this scale is so much better, so much more readable, so much easier to maintain. It just really represents what the hardware is doing so much better than this like mess. Like, I mean, this is, and like imagine if we had a way more complex system, right? Like this is going to get infinitely harder to read. The more states we add, it's going to grow exponential in complexity. This is just linear complexity adds, right? Like we just add a case for every state we need to add. But if we want to add states here, we need to modify all the logic in all of our previous events and previous cases. So that's growing exponentially with complexity. This is just way easier to read. So hopefully you appreciate it. Put together a little nice diagram for testing harness, right? So if we want to do a testing harness, we can just input an event state, input our coffee machine struct, it's a pointer, and just modify it and double check the logic of that outputted coffee machine. We're not checking these weird globals if we're like building a test harness, right? Like having these global flags with the test harness is super messy. This is way cleaner to be able to test also. Just pass a pointer and check the state of the pointer variables. So hopefully you guys appreciate this video. Let me know if you have any questions or anything that makes sense or you have an idea for something you need me to cover in the next video. See ya.